Back for future topics, because it's really going to be community driven. I mean, again, this is not all altruism. You know, we're doing this because we selfishly want to learn ourselves,
right.
And we have areas we want to learn, but we also want you guys to help drive the agenda. So that's really critical on the feedback form to fill that out for us. You know, and if things don't go well, definitely share it with us. If you didn't like the food, you didn't like the facility, didn't like Chris, I don't like him. So
I don't like me either. Mike doesn't like me.
I didn't like Chris.
Well said.
So any of that would be great, and please share with your coworkers. We'd love to grow this.
Right.
Definitely.
We haven't really marketed at Liberty Parks
haven't.
at all. I know I mentioned it to you, but we haven't really talked to many folks.
Yeah.
Yeah.
I put it in our team Slack today, but I put it in today.
Okay.
Yeah,
It's like the nicest day of the year, so I'm like, no one's going to come to this.
Right. It's definitely driven word of mouth. You know, I know Chris and I, we've done user groups before, so love to see this grow. And you know, we're hoping that this will help all the people that don't want to drive to Boston for the user group.
Yes.
So, you know, Tim held up the feedback form. Tim held up some cards. So the odds are excellent tonight that you're going to win one of these two.
Yeah. Don't make me take them home.
You need to fill out, you need to fill out the feedback form. We actually asked for Amazon gift cards, but too late to get those. So that's what
Tom
we
will
have.
provide those next week.
Yeah, that's right. Tom, AWS guy.
Yeah, an actual Amazon employee here, so be gentle if you want to criticize him.
Or don't.
I don't. Did you want to step up and explain the S3 outage, or we'll let that go?
Ouch! Too soon. Too soon.
Everyone heard, right? I mean, manual intervention.
Anyway, you guys are all here to see Brian. So
Yeah,
Brian,
let's do this.
coming, so.
And thanks, it's fun to come out here. It's funny, I had thought, drive up to Maine, and because there's also a Boston Amazon meetup tonight, and I was looking, I'm based in Lexington, and it's only slightly longer to get here. Once you figure the red line, the green line,
yep.
and all that. So we're going to be, there's actually two talks tonight. So the first is sort of the Amazon high-level survey, but we're also going to talk about, we're going to do a dive into an Alexa skill. So I brought a couple Alexa devices, the tap that no longer has to be tapped. So originally this was the, if you're afraid of Amazon being the NSA, it would only listen when you push the button. And then I guess we got over it. and Amazon offered an update, so this now listens all the time. Alexa, what time is it?
It's 7:04 p.m.
And so I tried to get them to duel, but they're smart enough to figure out just one to answer. So this is great because it's portable, and then we also have the dot that's powered. But so we're going to go over an Alexa skill, which is what we call Alexa apps.
I'm not sure what went wrong.
You can't say that. I can't say that thing. So.
And you were worried about the Amazon employee in the room.
Right.
I'm going to say Echo and Dot.
Yeah. I will say I went to an Amazon hackathon, and it was a room about this size, and they had a couple of Echoes around. And at one point I asked a question. I said, you know, how does? And this was when all the Echo devices were new, and I said, how does Echo device, you know, compare to Siri? And one of the Echoes over there said, we're completely different. And it's like, I wasn't even talking to you. But so we're going to go over. I'm going to demonstrate the skill that I've written, which is a skill to help control your kids' screen time with chores. And then we'll go over the code that you need to write that. And I have to say, just before we started, I got my wife had my 11-year-old son call me, and he said, "Dad, you're doing a presentation tonight." And I said, "Yeah." And he said, "Don't mess up." It's like, excellent, excellent. So feeling the love. And just tagging on the S3 outage. When that happened, there was a lot of email that went around my company about, you know, you know, let's be so smug about, you know, how foolish Amazon is and blah, 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 blah. And then someone said, what prevents that from happening here? Dead silence. Dead silence. So a system that lets an individual kill the system is a broken system, not a broken individual, I would say. But anyway, so blah, blah, blah. I've been doing Amazon for about 5 years, mostly as a developer, though when I first started using Amazon, I was at a 7-person startup, so I was the whole development organization and IT and everything. And they said, our product needs to be incredibly fast and incredibly cheap, and we don't care so much about resiliency. It's like, okay, that pushes you in a certain set of directions. And now, 5 years later, I'm a developer who's jumped into operations because we had some attrition in operations and we weren't able to keep the lights on. And we do medical security, so they're like, yeah, it shouldn't take too many seconds to do the thing, and it would be great if it wasn't horrifically expensive, but oh my God, it's got to stay up. So, which pushes you in another whole direction. Anyway. So please ask questions. There are, a million services. Nobody knows all the services. I saw a couple of the people. Last time I gave this talk, someone asked a question, if such and such a service exists. I said, no, it didn't. Then I refreshed the screen, and it did. So it's okay. So here are the services. That's a short version of the talk.
Okay, thank you.
Right.
Did you practice with your son? He said,
What?
did you practice this with your son and that's when he said, don't mess up?
No. He says, I mean, he's 11, so he says that all the time. He's at that phase where he says, Dad, you made another mistake. It's like, excellent. So the spin I wanted to put on this talk, because there's lots of different ways you can slice Amazon, but I think that there are really very, very different ways that you can look at how you want to use Amazon. You can spin up just raw machines. You can spin up a raw machine. You might be thinking, geez, I want to try some package on my local machine, not so much a Mac, I guess, but or a Linux machine. I want to see what happens, but I don't want to do it on my machine because I don't want to screw it up. Hey, I'll spin up an Amazon machine. It's expendable. I'll do whatever yum installs I want to do and carry on, and then I throw it away when I'm done. That's sort of one extreme. You can go to completely managed services. It's like, I don't care. I want a SQL Server on Aurora. I want there to be a database. I don't care about updating it. I don't want to care about backups. I don't want to care about resiliency. Just make the stinking thing work, and I'll pay the bill. That's another whole approach. You can go to infrastructure sets, and it's funny. Though I've been using Amazon for 5 years, it's only in the last year that I've really gotten into CloudFormation. And CloudFormation is, okay, I want a bunch of this, and a bunch of this, and a little of this, and a little of this, and put it together in a package and spin, the whole thing up. And so you can take that approach. Or you can do no server at all, which is Lambda. And when they first started bringing out Lambda, I said to some of my buddies, in 5 years we're going to look back and say, remember when we used computers? and so we got 2 years left, but we're getting there. We're getting there. I'm a big fan of this. So we basically want to just sort of take, this is the slice we're going to take, trying to look at different approaches. And I think it makes sense because, in part because we all have different backgrounds, and I'm sure I bet there are people in the room who know more about any one of these topics than I do, which is great. But it just gives you exposure to each of the things. Okay. So how many people have just played with spinning up EC2s? Just okay. So all right. So we don't need to get. We'll go a little fast on that, but and maybe I can even just skip the demo parts of this. But you can spin up any instances you want. The AMI strategies is actually interesting. There's the baked and the non-baked approach, and I've seen I'm very much in the baked AMI camp, and I'll explain that in a second. But I've seen people who are very much in the other camp. The idea is when you spin up an instance, you start with an AMI, which is an Amazon machine image, which is essentially the raw computer that you're starting with. But generally, you're going to have to add packages to that. And the question is, do you add the packages every time you spin up an instance? Or, and some people really like that, and you can do all kinds of customization, but that takes time. Okay? I was at an AWS talk about 2 years ago where we were doing basically sort of open mic night on how we did infrastructure. And some guys from Nokia got up and said, well, we run these incredible Puppet scripts and all kinds of downloads and updates, and you know, within 45 minutes after an instance has started, it's doing useful work. And I run spots where if they run for 45 minutes, that's a long day. And I said, well, okay, I do baked instances, and within about 45 seconds, they're doing useful work. So there are people on both camps. But as an example of a use case you might not think of, at one company I worked, we actually did all our, we made our development machines EC2 instances actually running spots, and we'll get to that in a minute. But basically, we baked in that it was, you know, the Linux image that we wanted, the version of Java we wanted, the version of Eclipse we wanted, you know, Git pre-installed. You know, you would fire up an instance, it would come up, it would have everything you want. You'd SSH into it and say Git pull, and you're running. You know, you're running immediately, and so that's a real value. If you have instances that only run for an hour or so at a time, you don't want to waste all that time recreating them, especially if you have lots and lots of them. On the other hand, if you have instances that are going to be running, you know, months or years, good luck a little bit with that, but because hardware still breaks. And if you're not necessarily going to run lots of them, well, you can get away with it. I mean, if you're spinning up, I mean, we spin up, you know, 8 or 10 Cassandra nodes, and we expect them to run for 6 months. Let it go. If 45 minutes at the front end doesn't matter too much to us. But so you have to make those kind of decisions. Instance types. You know, it's funny. I've got a list of instance types later on that's already out of date. But we go from the, you know, absurdly small to the crazy large, and at reInvent they redefine, you know, as they always do, they redefined what crazy large is again. So there's, you know, all kinds of instance types, different purchasing options, and we'll talk about that a little bit more, all kinds of options for monitoring, and then, and again, you can see this slide is old because once you have an instance, add volumes, add IP addresses. Now you can add GPUs to the mix on some of the instances, which is kind of interesting. So,
Ryan,
yeah.
Is there any kind of report out there showing the breakdown between classic EC2s and Lambda? Just usage of the platform? You seen anything like that?
You know, I haven't. I mean, that's it's interesting. I mean, it would be hard to quantify. And so, jumping ahead for people who don't who aren't familiar with Lambda, Lambda is basically you don't spin up you know, any infrastructure at all. You write some code, you load the code into the system, and then the code gets invoked and run. And so you're not provisioning anything.
You'd have to like compare.
So actually, the thing is, in your case, it would be different, okay, because whatever you can do on an EC2, apart from really hardcore real time, you can do with Lambda, because you have to do a combination of Lambda and like maybe S2S. So store your results in a queue because you have a 5-minute execution time thing, and then you can scale back horizontally, and you can use also AWS the step function, which is a state diagram. So there's no reason for you not to.
Well, that's why I was asking. So
Well,
just a little
Right.
background. I went out and did an IoT thing with Amazon last year, and they basically considered, at least the team I worked with, they considered EC2 legacy, and they used to say you should do everything with Lambda unless you can.
Right.
So if you go over that, I thought it was 3 minutes, but maybe 5-minute
Yes.
execution time.
Right. Part of the thing is, and step functions, that's a really interesting notion. So one of the things is that to think about or to understand with lambdas is basically, you know, you've got your basically your whole infrastructure C of AWS, and lots of things cause events to happen. So, actually, for a little demo, if a couple people could give me your a cell phone number, I want to add it to basically I just want to trigger.
Yeah, call me.
Yeah, I'll basically. You'll get triggered by a demo, and then I'll delete the rest. I'm not going to spam you, but as my wife said, Brian, stop spamming my phone with with messages coming in. But whenever an event happens, so like someone puts a file in S3, or a row gets written to DynamoDB or something, an event gets sent into the system. Lambda.
It's tuning.
Yeah, sure. Basically, a Lambda will respond to that event and process it, but it does so in essentially a very limited way. Now it can, it's supposed to be a very short-lived function. They've expanded that now. It can run for up to 5 seconds or so, but you get charged by the in 100 millisecond increment. So it's intended to be short. But then very often your Lambda will fire off an event that will trigger off another Lambda, or you can call make calls directly. So prior to step functions, it's actually kind of interesting to figure out what's the unit. If I mean, the classic example they gave is I upload a file to S3, and it's an image file, and I want to generate a thumbnail. So I get a Lambda receives the event, the notification, the new file was updated. It then goes and gets the image, it runs some transcoding, and it sticks a new thumbnail file back in S3. And then you want to make sure that doesn't trigger another round trip. But what's the unit? If this was run on EC2s, you'd say, okay, maybe I have an EC2 instance running, and that's my unit of cost, my infrastructure. But in the Lambda case, maybe I've triggered 2 Lambdas that each ran for a couple hundred milliseconds, or maybe one that ran for 10 milliseconds, the other ran. It's not clear how to count them. It also, again, before step functions, when you have a Lambda responding to an event that fires another event that fires a Lambda, great, you can keep track of it. But there was this whole notion of what do you do when the graph essentially gets into a dozen nodes and maybe a dozen edges or so, and this Lambda is triggering this Lambda, triggering this Lambda. It gets actually kind of interesting. And I actually wrote a little paper that I should reference here, but I didn't. Bad on me. On how to do that with Node.js to make actually a graph tool. But step functions, which is deeper than I wanted to cover here, basically lets you essentially draw the state diagram of how you want the Lambdas to interact with each other, and how to handle errors and retries and all kinds of things like that. I think state functions, I'm very curious to see what they say about state functions this year at reInvent, because I think that's, when they introduced that last year at reInvent, I said, okay, this is actually the sleeper feature. So, good question. Anyway, okay. So, and it's just some examples of instance types. You can go from, half a gig of memory to 2 terabytes of memory, and I think actually you can go much higher now. I mean, this is, like I said, this was a slide that I wrote before the last reInvent. You can go from 1 to 128 cores, 48 terabytes of storage. Some really interesting, price differences, and then all the various instance types. You can, and one of the flip sides of these instance types is you can make better or worse use of this depending on how well you understand your application. Some of the instance types are memory emphasized. They have more memory. Some of them are CPU optimized. Some of them are network traffic optimized. So it's, and then a lot of us use the M-class machines because we don't know. Because if you don't know, you typically say, oh, I'll do an M2 4x large because I have no idea. I'm just running Java and I'm not monitoring it well enough, so I'm going to guess. And that's fine, but you can do better. But you have to do monitoring. And in addition, there's also now the burstable types. So one of the people familiar with burstable? Yeah. A little bit? Anyone not? Okay, all right, for a little bit. So one of the things I love about Amazon, and I don't work for them, though it feels like I do sometimes, is that they really tend to find answers to or solutions to some of the problems we really face. A common use case is that you've got a machine that is mostly idle, but then it gets some load applied to it, and it's an intense load for a little while. So we have authentication servers. It might sit there completely idle for a day, and then everyone logs in the next morning at 8 a.m. and you've got a spike. The burstable instance types, basically the T-type classes, you pay for this much machine of this class, but if you're not using it that much, you build credits, and the machine has the capability to do more. And then when you get your burst of load applied to the machine, it can pretend to be a machine like this for a little while. And that's tremendously useful. And the burstable types started on the low end, but now they've gradually gotten bigger. I'd like them to be getting bigger faster, but there's the T2 medium and T2 large, but I'd like to see the T12X large, but then they've also gone the T2 micro that's, teeny. So again, you can make more or you can make better use of this to the degree that you understand your workload, which involves monitoring. So all kinds of crazy instance types you can do. Pricing models, and I will say I'm a huge fan of spots. I've made done a lot of work with spots, but there's basically 3 ways that you can pay for EC2 machines. You can pay by the hour, just straight on demand. I'm going to spin up a machine. That's the default. I'm going to spin up a machine. I pay for all the hours that I use. Keep in mind, you spin a machine up for 10 minutes and tear it down. Spin up another one, use it for 10 minutes and tear it down. That's 2 hours of charging. It's the hour or the part of the hour. And Google and I think Azure, do it by 6-minute increments or something. But having used Azure, it's not worth it. Just in my opinion. But if you're just running a small number of instances, that doesn't really matter. If you're running lots and lots of instances, you pay attention to it. Okay. Then reserved instances, where you basically say, I know I'm going to have 50, 10 or 50 or 100, whatever, of a certain class of machines running all the time, or I'm going to have at least that many running all the time. So I'm going to pay you up front and reserve that amount. You can actually save a tremendous amount of money on that. So like at our place, we're just starting to switch over to reserved instances, where we have like I suppose I can say, we have tens of thousands of dollar bill a month, and we think, a lot of that is machines where we're always running them, we're always going to be running them. We might as well reserve them and pay the lower price. Now, when you do reserved instances, if the reservation is based on the type of machine. So you do a reservation for an M22X large or an R3 4X large.
Question on that one. Did you use a third-party tool or anything, cost optimization tool to figure out how your reserved instance is purchased?
Yeah. We're just using just starting to chat with Cloud Health.
Yeah.
Cloud Health is giving the talk at the Boston AWS meeting tonight, actually. So they actually have they can put a monitor on your system. They put a monitor on our system. They watched us for a week, and they said, "Whoa, we can save you a couple $100,000 a year." And we're like, "Tell us more,"
The benefit of I'll give a plug for AWS meetups. Is actually I met the founder and CTO of Cloud Health at the first AWS meetup in Boston 4.5 years ago. It was pretty ironic. He was a one-man show. He was literally him and another person started up Cloud Health 4.5 years ago, and now they're like major companies.
Right. Well, when your value proposition is you can walk in and say, we can save you $4 million a year.
Actually, Lucid Chart, I do not know if you've heard of them. It's like the cloud version of Visio. On the AWS reInvent, they just launched in which you can just put the key, if you're a key administrator,
Mhm.
it will diagram your whole infrastructure, and it will also map your cost.
Oh, that's interesting.
Graphically.
No, Lucid's great, yeah.
Yeah, usually.
That's awesome. And one of the, because Amazon is always adding things, recently there's convertible reservations.
Yes.
So we just got into that. So you can say, well, I mean, so like right now we're looking at upgrading our Cassandras. We're running them on, you know, a certain class of machine. I think we're probably gonna go to another class of machine. But you can buy a convertible reservation, and it's Cloud Health. Cloud Health actually doesn't parse the convertible situation quite right yet, but they're working on that. But you can say, I want to get a reservation that would cover this range of machines. Now, when you do that, you don't get quite the discount you do for a regular reservation, but it's still a discount. There's also a marketplace where, because the thing with the reservations, you're locked in for either a year or for 3 years, and you pay an upfront cost and then lower cost for the reservation. So, like in our case, the value proposition is, hey, give us $100,000 up front, and over the course of the year, we'll save you $300,000. And you know, you have to talk to your finance people to work, you know, to work that out. But reserved instances, if you have a constant set of machines that are running, you really should look at reserved instances. But first, you should look at spots. Spots are just the berries. So remember, when we're reserving machines, we're going against this giant pool of Amazon machines. And to put it into perspective of just how giant a pool of it is, I'm trying to remember his name. The Amazon's chief evangelist,
James Hamilton.
Burr.
James
Jay Barr.
Hamilton?
No,
Jeff Barr.
Jeff Barr. Yeah. He came out to the Amazon Boston meetup about 4 years ago, and he gave us this stat. He said, if you look at the computing infrastructure that Amazon retail had back when they were a little $5 billion company, that's the computing resource that AWS adds a day. A day. And that was 4 years ago. So I mean, it's crazy large. So whenever you have that large marketplace, there's always room at the edge. And so spots basically let you bid on the unused capacity. And you can bid on capacity by region and by instance type. And you typically pay about 13% of the cost of what a normal instance would go for. Now there are some caveats, of course, in that the instances can disappear. Okay, so, but of course Amazon has given you caveats to the caveats. But back when I was first doing spots, the instances would just disappear out from under you. So in the application that I was doing at my first place, we were doing financial modeling, where we had to do, essentially creating this giant multiverse of possible financial situations. And so we had an algorithm that would break things up into these little 15-minute work units, but like 20 or 50,000 of them, and would have customers say, hey, can I have that analyzed by lunch? It's like, sure. So I'd spin up 10,000 spot instances, which is ridiculously cool. When you say, I would like 10,000 instances, please, now. It's more fun. It's more fun when you do it on purpose. So we wrote our own custom scaler, and we'll get into that in a minute. But basically when there's too much load, you can say I want more machines. When there's less load, you can take more machines away. And we actually wrote a custom scaler that paid attention to the charging hour boundary. And so basically, if we had reduced load and the system wanted to take a machine away, we would say, is there any machine that's within 10 minutes of the next charging hour? And if there wasn't, we would leave it alone, we would not scale down because new load might come in. Okay, so, and it actually saved us just crazy boatloads of money after I got the algorithm right. So, so the first time I ran it, it's like, you know, I was just doing little tests, capped at 10. I have one instance, I have 2, I have 4, I have 8, I have 16, I have 64, I have 250, what the hell? And, you know, I had gotten some condition wrong, and I was consuming the East Coast. Luckily, we were storing our init script on S3, and I finally had the right idea to rename the script so that no more machines would spin up, because you know it's the sorcerer's apprentice thing. You can't kill them fast enough. So, and we've all made this mistake, and you know, in the end, I only burned through about $35 for the 5,000 machines I spun up for an hour. But so be it. But the thing is, back then, instances would just go away. So, and actually, let's look at the pricing model, because that's really pretty cool. Yes, I'm not going to socket. Okay, so this gives you the price. In this case, for a C3 large over the last 3 hours. And the on-demand price is about 10 cents, and the various zones were at, tiny amount. That's pretty cool, okay? But let's look at some bigger ranges. Okay, this is not. Look at the great variation that the system is providing us. Let me pick something else. Okay, now it gets a little interesting, but not as interesting as I wanted it to be. There we go. Okay. So you're happily running along, and then basically someone can, you're saying, hey, I'm willing to pay 21 cents. Or I'm willing, to cap my bid at 50 cents or something, and then the price goes above what you're willing to pay, and your instance gets taken away, and it's just gone. Now, at this point, you get a 2-minute warning, and you can caveat that as well. But essentially, what we found was our instances would just disappear out from under us. Now, that can be, you can view that as incredibly awful, or you can say this is going to force me to be reactive. Reactive is one of the buzzwords we're supposed to be. We're not object-oriented anymore. We're not whatever we were supposed to be after that. Now we're all supposed to be reactive. And so we're all supposed to be, embrace failure. Failure happens. Well, spots encourage you to deal with failure because it is going to happen. So that's actually one of the reasons I really quite like spots is that you must be resilient. You must have your system be able to restart, checkpoint data, and carry on. Now, one of the things you can also notice about this is that the different zones behave very differently. So if you were in, if you were in East, 1D, you wrote out quite a lot of it. If you happen to be in 1E, there's a lot of spikiness. Now, the other thing is that a lot of people don't know is your 1D is not my 1D. We each have, 4 or 5 zones, but there's absolutely no guarantee that A is the same for all of us. In fact, we're told it isn't. Okay? So this is one of the things that Amazon goes out of their way to do is not give us information that would let us rely on that information. So one of the other things is there's a maximum amount you can bid on a spot instance. At least back when I was doing a lot of spots, they wouldn't tell you what it was. They just said, there's a maximum amount, and if you bid too much, we're going to reject the bid. In a similar way, has anyone ever seen the request limit exceeded message?
Yes.
Yeah, lots of us have been bit by that. It's when you made too many API calls to the system. How many is too many? Too many is too many. Well, that's lovely. So we've all learned to write the backoff, the little backup bit of code in our method say, oh, I made the call. If I got this error, I should retry, and I should do an exponential backoff. And especially when I was running 10,000 spots, I would very often get that kind of request. I mean, one of the things you have to then think about when you're running these large fleets, that is an intentional segue, fleets is that any call that all of your instances may contribute to the request limit exceeded thing. And so you can get into situations where you're handling a load, you add more instances, and everything's great, and your scaling is all wonderful, and then you hit the request limit exceeded, and then everyone craters. So you have to, be fairly proactive about your exponential backoffs. But, or I should say, Amazon has continued to make spots more interesting in that you now get a 2-minute warning that your spot is going to go away, although you do have to pull for it. But they've told us that down the road it will be an event, not a poll, but they're not there yet. You can also do spot fleets. So one of the things that comes out of all the various instance types is that there may be multiple types of instances that can handle your load just fine. So an M2 2x large is really pretty darn similar to an R2 3x. Yeah, it's close. For most of us, there's probably a half dozen instance types that are good enough. Okay. So what you can say is, I want 100 machines spread out on my 4 or 5 zones, and I'm willing to use any one of these 6 instance types. Cool. What did that buy you? Well, you notice when we looked at the different charts, each of these pricing charts for a different instance type looked very different. It's a matter of diversifying. If you've got 100 machines spread out on 6 different instance types, each instance type on each availability zone is a completely separate market. Okay? So you are unlikely to get killed in a bunch of markets at the same time. Okay? The other thing that's important to remember about spots is what you pay. And I found this. It's not a checkoff auction. It's a Vickery auction. There's this whole wonderful paper about what's the best type of auction. And there's this type of auction called a Vickery auction where you pay the winning price on an auction is actually the second lowest bid, not the top bid. So let's look at this. Suppose I was wanting this instance type, and I wanted to be pretty sure I got it. And I was saying, I'm willing to pay up to 50 cents. I get my instance. I don't actually pay 50 cents. I pay whatever the price is here. So I pay this price, not the price that I bid. As the price goes up, I will pay whatever the price is, for that hour. Essentially, it's probably the max of whatever the hour charge is. So that's where we get into the whole thing of what's the maximum price you can bid, because some people say, oh, I'll bid $10, knowing that no one will ever take it out from under me, except when they do. But there are limits. But you can safely bid a modest amount, knowing you'll probably only get charged this amount. So spots are wonderful. Spots are wonderful. Fleets make them even more resilient. They've added even some other things where you can do spot reservations on date and time. So you can say, I really need a bunch of machines from 3 p.m. to 5 p.m. on a Friday. And you pay less than on demand, but more than regular spot, because you're making a reservation, so there's a bit more of a commitment. So you can play all kinds of games with pricing. And if pricing isn't important to your situation, I want to know what that situation is, but it's when I'm running 10,000 instances, it really matters. Less so if you're running a small number of instances. But anyway, so spots just rock. let me go back to questions. Sorry, just that goes without saying. Questions. Okay, so again, continuing the slice. So that's all that was basically if you're running instances as you know, you're just spinning up a bunch of instances. It can be if you're running something that Amazon doesn't provide as a service. So like it's interesting that with all the database options that Amazon provides, they don't offer Cassandra as a service, which is kind of interesting. You know, I wouldn't be surprised to see that come along at some point because a lot of us run Cassandra. But if you want to run Cassandra, Amazon doesn't have an offering for that. So you end up spinning up, you know, your 8 or 10 or whatever instances and basically rolling your own. But then you're responsible for it. You know, tomorrow morning actually I'm having to do some serious maintenance on our Cassandra system, and I'd rather not have to. But anyway, but so Amazon provides all these wonderful services. You have you know databases. You have Dynamo. You have Redshift. You have all the Aurora systems. People familiar with Aurora?
Yes.
Okay. Okay. Cool. All right. Basic.
Is that MySQL?
No, it's
Is there
it's
flavor
more
of
than
it?
MySQL.
Well, yeah.
Well, basically, it started off as MySQL. Well, there's you know RDS, which has various flavors, and then Aurora. Basically, they said MySQL, pretty interesting database, but it's not designed for the cloud. Why don't we take some of our apparently infinite resources and do a ground up wire compatible version of MySQL that's designed for scaling, and resiliency and sharding and all that wonderfulness. And they did it, and they said, oh yeah, it's 5 times as fast at 1/5 of the cost.
Yeah, and now they have the Postgres also on the Aurora SQL.
Right.
I see.
So, unless you're running Cassandra, I'd be hard pressed to not use one of their services, database as a service, just because they provide the scaling, they provide the resiliency, they provide the backup, they provide the updates, they provide the security updates. Why would you not? Disk as a service, a couple different ways. S3, you can put your files out on S3. Ridiculous number of 9s, resiliency. Again, the S3 outage made into that a little bit. But they didn't lose files. We lost access to files for a little while. But I mean, correct me if I'm wrong, but I don't think anybody lost a file.
Right.
And that's pretty astonishing.
They kept their 11.9s of durability, but they did not make their 5.9s of availability or something.
Right. But 11.9s. I mean,
Yeah,
11.9s.
Still awesome.
I mean, we used to joke, I can give you 9.5s,
It's very difficult to get 11.9s.
What?
It's very difficult and expensive to get 11.9s.
Oh yeah. And then, so I mean, basically, you put something on S3, it's not going away unless you wanted to, and then you can. But then, of course, then they give you reduced redundancy, where you pay a little bit less for maybe 7.9s, instead of 11. But even 7.9 is absurd. And then you can stick them onto Glacier if you want. Glacier's for. I really don't think I'm ever going to need this, and I'm so screwed if I ever need this, but it would be better than not being able to get it back. I mean, when you pull something back from, it's practically free to stick something into Glacier, but pulling it out is fairly expensive and fairly slow, like on the order of like 4 hours.
No, they actually just recently launched something that if you're willing to pay a premium, they can get it out for you in 5 minutes.
Of course they did. I mean, I would joke that they couldn't do that an hour ago, but yes, of course they did. But even if 5 minutes, but even 4 hours, if your whole system has cratered and the alternative is you're just screwed because all your backups are gone, 4 hours is better than a dead company. So there's that. There's also the Elastic File Service, which I haven't really played with, but basically it's NSF disks.
It's actually faster than, you can connect up to 1,000 EC2 instances to that, and it's faster than any of the high-end EMC slash, all the other ones like Meta.
Right, right.
And it's like scales, it scales horizontally and vertically,
Right.
and you just pay for as much you use.
Yeah, now it's funny because EFS was spent like 6 months or so, you know, as a beta, as a one of these services where you're like, oh, they're really going to go anywhere with this, and so a lot of people held off, but it seems like now it's really, you know, come into its own. Load balancing and auto-scaling, which we'll get to, and I got to speed up. Monitoring, better be monitoring, and authentication, and auditing. So I'll just mention, you know, CloudWatch is where you get your metrics for, you know, what's going on. You can use all the standard CloudWatch metrics. You can write your own. Writing your own is a very, very cool thing to do because you know because you know what's important to your system. Just caveat: you should know what's important to your system. If you don't, you'll find out after the fact. It's better to find out before the fact. And then auditing cloud trails. Basically, anytime, and you should at the reInvent talks, whenever they're talking about cloud trails, they say if you don't have cloud trails enabled, leave the talk and go enable it, and then come back. Basically, Cloud Trails keeps a record of every API call that's made to your system, ever. And again, though, when they first started that, they would do every API call. You couldn't say I want this group or this group. You couldn't just say, you couldn't say, you know, any calls that are made to, you know, the AMI interface, the IAM interface, you know, record, and all the other ones I don't care about. And they didn't have any really good query tools, so you know, you would generate, you know, these billion-line log files, and we all wrote scraper scripts. And they've improved that. Now you can spit it through Spark, I think. Now. So.
Yeah, they have a thing for what's that Presto thing, which not Alexa. You know what I'm talking about? They're offering Presto as a managed service.
Okay.
So you can actually hook it up straight to your CloudTrail, and you don't have to use the hide thing.
But you should be doing. I mean, you should be monitoring your system. And then the next.
Quick question on the database as a service.
Yeah.
They automatically do all the upgrades for you, let's say security patches and whatnot. Do you have any control over that as far as when you would want that done, or can you?
You have a maintenance window which you can specify.
Yeah.
Okay, and can you? What's that? I mean, I did e-business suite stuff. So can you back it out? Let's say if you had a problem with the upgrade.
You have snapshots, so you can always restore back.
So you can restore back and then tell them, give me the database as of whatever, and yes, don't do it anymore. Or,
No, you not don't do anymore.
well, for
Yeah.
postpone it till you figure out what it
Yes.
is.
Right.
Okay.
Right. But that's a better problem to have than, wow, I haven't done the security patches in a year and I'm screwed.
Right.
Right.
I've done enough to know that you got to back them out every now
Right.
because let the application catch up to the.
Indeed.
Okay.
Yeah. And Elastic Container Service, this is basically the service for running, if you're running Docker. A lot of us, you know, a lot of people are running Docker containers now, and ECS is basically a scaling service for running your Docker containers. I'll give you, I've got a better picture of that in a little bit. And besides the container service, there's also a Docker repository. You don't have to use the Docker, Amazon's Docker repository. I will say it's kind of slow, at least in our experience, so we don't use that one, but so be it. And I'm just going to sort of whiz through this. CloudFormation is where you say, you know, I want a little of this, I want a little of this, I want to pull the pieces together and run them as a unit. And one of the things that's really that I've actually found really quite interesting with CloudFormation is that they have a sort of subsidiary tool called CloudFormer, where you can manually create an infrastructure, you know, because sometimes you want to design the infrastructure in JSON, in a template, but sometimes you just want to say, well, you know, I want to spin stuff up, I actually want to get the things running, and I say, that's what I want. I want to do this. And CloudFormer will basically take a snapshot of what you have and let you do it again. So CloudFormer is actually a very, very interesting tool. And I'm running out of time, but you can look at if you go into CloudFormation, you can look at, there's all kinds of sample templates you can look at to show you examples of using that.
Is CloudFormer something that's offered, that's something separate, it's actually offered by Amazon?
Yeah, oh yeah, yeah. So auto-scaling, I'm sort of squeezing this in, but for a lot of us, this is the reason, you know, we go to the cloud, you know. Basically to handle failures and load. I mean, an interesting use case for auto-scaling is, you know, I have one instance, and I always want to make sure that there's one instance. And I don't need more than one, but I need there to be one. You know, you can set an auto-scale group of one. And, you know, if it fails, you'll spin up another one. So it doesn't have to be, oh, I'm auto-scaling, you know, a million machines. It can be, no, I'm auto-scaling one machine, and I'm trying to be damn sure that I always have one machine. But it also can be for the load. And so you generally have three components. You have your auto-scaling group that says, okay, I want to launch these kind of machines. I want to have, you know, minimum of this number. I want to have maximum of this number. You know, I'd like to have this many. You have your load balancer that sits in front of that says, okay, I've got 10 machines. You know, I want to then distribute the load, you know, my outside load to those 10 machines through a load balancer. And then you also have a launch configuration. Because when the autoscaler says, I want another one, it's like, another what? Well, you know, so you have to tell it exactly, you know, the configuration, I want this kind of machine with these, you know, these kind of options and so on. So those three things go together. And so here's
Question.
Sure.
On the Elastic Load Balancer, do you go between the classic versus the application load balancer?
And here we get sort of to the edge of my expertise on that.
Sorry, what was the question?
But-
The differences between the application load balancer versus the classic load balancer that they just released.
The big one that they just announced for that is host-based routing for the application load balancer, which is, I needed that about 2 years ago. So that's a big one. So if you want example.com to go to these instances and domain.com to go to those instances, you can do it with one ALB now. Whereas with the ELB, it's just kind of like a blind round robin type
There was something about
configuration.
forwarding too. You could use an exporter form with one of them, but not with the other. I can't remember the specifics. There's a really good white paper on exactly the differences between the two.
Yeah, the biggest difference is the classical load balancer is a network load balancer, so it's based on IP address. So the traffic's going to come in, and you can have a bunch of applications running across a bunch of instances connected to that ELB, and it's just going to spill them and send them out there, right? But if you have different applications running across that same instance, right, and you want to direct those applications to certain instances because they're running at certain instances, that's where you run the application load balancer. So it's application aware. The other one is just IP aware, so it's just network aware. So it's just going to throw the traffic at these instances.
Can I do HTTP to HTTPS redirect
Yeah,
to the ALB without having a separate Nginx server running behind that ELB?
Yeah, you can do redirects, yeah. Does that make sense between the classic and the
Okay. Okay, interactive, excellent. So I just wanted to give, you know, basically pictures are good. So this is pretty much what we're doing in at least one case. You know, we have a CloudFormation template that sets us up with, you know, an autoscaler that has a launch configuration to use to spin up a type of EC2 instance. It happens to be using an ECS optimized AMI, which means that AMI comes preloaded with the ECS agent. Okay. So this EC2 instance starts with the container. It runs a Docker task. It pulls the Docker task from a Docker container repository. Could be Amazon's. We happen to be using, you know, another one. There's a file that gets pulled down from S3 onto the instance that says, which ECS cluster do I want to go to? When the agent starts up, it reads that file, it attaches the task to the container service, the Docker task finishes its startup, and ELB sees that new instance as in service, and now we're ready, to servicing. So it's actually kind of a sweet dance. And ECS and Docker, there's the whole giant infrastructure. There's lots and lots of meetups about that. There's all decisions you can make about, do I want to have, one task per container? Do I want to have one container per instance? That's application specific, but you can make all kinds of choices. But this is just an example of how you might use all these pieces together.
Do you guys use Docker?
What?
Do you use Docker? No. You have
Yeah.
a company? Yeah.
Yeah.
Just curious.
Yeah, Docker's.
You made a comment earlier intended for you about how slow it was.
Yeah, I heard that, and I know, that's why I was curious, because I know there's, it doesn't seem, there were security issues at the beginning, it seems immature at this point.
What we've seen is that Amazon's Docker repository might not win any speed awards, but Docker and I sort of have a love-hate relationship with Docker in that the standardization is very, very cool, but it does provide another level of interaction, which is good, but also can be when you're trying to troubleshoot things, it's unwinding it. If the container fails on startup, where do you look for the logs? And you can find all this, but it's just more complexity. Complex is good until it isn't. So I want to get us to the Echo stuff. I'm not going to say that name. And then Lambdas. Lambdas rock. Okay. And then there's like a million others. We're actually going to do a little Lambda demo here in just a sec. There's machine learning, there's Poly, there's Lex, there's speech recognition, there's speech production, Mechanical Turk. People know about Mechanical Turk? Yes. This is just blows my mind. So suppose you want to do a task, or suppose you don't want to do a task, but you need humans to do the task. Well, farm it out. So you create a task definition. So one of the typical things is look at a picture of a receipt and decide whether it looks like it's a business appropriate receipt or not. Well, you can fire that off to a Mechanical Turk system, and you can say, I'm going to pay 2 cents for every receipt that's looked at, and you can decide whether you think this is a wonderful thing or horrible exploitation. But there are opportunities for getting swarms of humans to look at a thing. And an interesting case that was presented maybe it was last year's reInvent, with combining machine learning and Mechanical Turk, where a company wanted to be proactive about looking at their customers' Twitter feeds about the company. And so they wanted to say, okay, some tweets are really bug reports, and some tweets are really, we're about to lose this customer, we better do something about it. And some tweets are happy customers that maybe we can upsell to. And so they used a Mechanical Turk system, and they fed 10,000 random tweets into the Mechanical Turk universe, and they said, categorize all of these. And then, considering those as accurate scores, they fed that into a machine learning algorithm that from then on could automatically look at tweets and basically bucketize them. So it's a very interesting mix of things you can do. I mean, Mechanical Turk gets no love, but it's interesting. There's the whole code for continuous operations. Who's using Git? Okay, yeah. Amazon, of course, has an offering. You know, there's code commit, code deploy, code pipeline, and there's the fourth one. I'm trying to remember, but you can.
Did you say code deploy? Code
Well,
pipeline?
I thought there was a fourth. I thought there was a fourth one.
There are.
But
Yeah, I can't think of it either.
yeah, but you basically you can have, you know, you can set it up so that you're checking into essentially Amazon's Git, which will run, you know, a set of tests that will then, you know, promote things from, you know, devs to staging to, you know, red, green, blue, you know, and so on. I'd be curious to see how many people are doing that. I think more people should be doing that, but it's I think there are DevOps organizations where it's like, oh no, this is my turf, you know, stay away from it. But we'll see how that goes.
Code build.
What?
Code build.
Okay, code build. Code build. Yes. The alternative to like TeamCity
Jenkins,
or
Jenkins.
Jenkins. Yes. Jenkins alternative. Again, I mean, I think lots of us are probably in the situation where, you know, hey, my builds are getting queued. Oh, I should spin up another Jenkins server. Oh, crap, how well did that go? Why should we be doing we shouldn't be doing that? That should be AUTOSCALING. And then there's, you know, Snowball and Gateway. There's a million other services, but I actually want to move on. Go to the first slide where it said that there's a million other services.
Actually, one of the good things about Snowball is many people have some very real-time requirements. They can't rely on network throughput, so it's a local S3 with Lambda like on-premise Lambda, and it's got a very fast. It's like a network attached storage.
Okay, I wanted to show you a Lambda, and I'm sorry, I'm just gonna, just for instance of time, I'm not gonna make it use these extra guys, but
You come back in June for an entire Lambda session.
That's
right.
Yeah, little promo for you.
So, okay, so this is some. Unfortunately, I have a. Text me. Okay, yeah, text me. Okay, right. So, and we'll skip over that part that I need to upgrade because they're no longer supporting that version of Node. So we'll just scroll. You never saw that. So this Lambda, you know, it's a handler function that gets called when something gets uploaded to my S3 bucket. And so you can see it comes in. I have the event itself. I have the context of the event. You know, I can pull information out of the record. I can get the name of the S3 key. You know, I can write a log, start with Brian's SNS function, and then I call, you know, SNS, and I do a test publish, you know, to a simple notification service, another one of the services we didn't get a chance to talk to. And this is my ARN, and an ARN is an Amazon resource name. Yeah. It's just an ARN, and so it's going to a Lambda topic. And so let's go look at SNS, and I have topics, and I have a Lambda topic, and I've got various people subscribe to it. And just in the interest of time, let me just turn this off of silent mode. I'll turn the volume up. Let's see if this works. So I'm going to go to S3. I'm going to go to my Lambda event source. Notice how clever my names are. The Lambda event source goes to the Lambda topic because I can't remember, and my function is called text me because I can't remember
Makes it
stuff.
easy.
Yeah. So I'm gonna grab a file. Oh, come on, this always works.
Or it takes a little while.
Oh, there we go. Oh, it's because it's on my watch. There we go. All right, fine. And you can't really see it, but it says, test published to SNS from Lambda for Brian's Lambda event source and Casino1.pdf. So, and it's more impressive when I have a whole bunch of the phones ringing at the same time. But just pretend you heard that, and and I'm pretty sure my wife's phone just went off too, so I may get another text saying, knock it off, Brian. But you can see it's pretty simple. I mean, it fits on the screen, and most of it is the error handling. You know, it's essentially, you know, grab the bucket, grab the key, instantiate the SNS variable, you know, and then call publish. I mean, think of what you'd have to do otherwise to get a text message if someone uploaded a file. It's kind of amazing. So, anyway, so with that, let's switch to.
I got one question on Lambda. Are you concerned at all with vendor lock-in?
Say it?
Vendor lock-in.
In this case, I love vendor lock-in. I mean, here's the thing. I mean, I sound like a fan, but it's like, am I concerned with going with the player that has 95% of the market? Yeah, no, I'm not. I've used Azure. I'm not worried. And other people will come up with, you know, they'll come up with Lambda, but on most things, Amazon is on version 12 of things that Azure and Google are doing version 0.9, from what I've seen. But so I want you guys to keep winning, because every time you win, you lower the price.
You get commission from Amazon?
No, it's what? Well, yes, my commission is my paycheck the last 5 years from people, not from Amazon, but so anyway. So well, let's start here. Okay.
That's great.
Yes. So my app is called More Screen Time, and so we know all kinds of if you have kids, or even if you have a phone and you're looking at your phone at night before you go to sleep, and then you wonder why you're not getting a good night's sleep. Too much screen time causes all kinds of horrible things. You know, so but you pick your battles. It's like, you know, the 10th time the kid says, "Can I have more screen time?" I used to be an animal behavior researcher. You better not give in on the 10th time, because that's variable intermittent reinforcement, and you'll never get out of that hole. But we do. We all do. So Alexa, let Alexa do it for you.
So what's the code word? You have to have your start field, right?
Okay, so I'll give you a demo. Alexa, ask more screen time.
Welcome to Screen Time. Say help to get directions. Checking your afternoon chores. Have you walked the dog?
Yes.
Have you folded your clothes?
Yes.
Have you fed the cats dinner?
Yes.
Yes. You may have 30 more minutes of screen time.
Or, Alexa, ask more screen time.
Welcome to Screen Time. Say help to get directions. Checking your afternoon chores. Have you walked the dog?
Yes.
Welcome to more screen time.
Do it.
Well, thanks, Alexa.
Denied.
Okay. Well, actually, that gives us an unexpected segue. So let's actually follow up on that. So I wanted to show you something else, but so let's go to the more screen time function, and let's look at monitoring. Okay, you can see that we got triggered a couple times. And God bless her, she's not admitting that there was an error, but there was. So let's look at the logs. And it was the most recent log. And isn't this so cool? I don't have to go SSHing onto something. I don't have to FTP anything. It's just right there. About to get the chores. Da 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 da. And okay, well at this point it's not telling me what's happened, but very often, I mean, when I was developing this, I would get a stack trace in here. Let's try one more time. Alexa, ask more screen time.
Welcome to Screen Time. Say help to get directions. Checking your weekend chores. Have you walked the dog?
Yes.
Have you found your sports gear?
Do I have to?
You have not completed all your chores, so you may not have more screen time. You have walked the dog, but you have not found your sports gear, folded or put away your clothes, fed the animals, eaten breakfast, picked up your room, done your homework. And remember, all those electronic devices talk to each other, so we will know if you cheat.
My son said, "Are you telling me that Alexa talks to the Xbox?" And I said, "Yes, that's what I'm telling you." I don't know.
Take my money.
Right,
I have
right.
a 4-year-old, take my money.
Yeah. Now the interesting thing is, and I'll say this with the Amazon representative here, so I actually demoed this at an Alexa meetup at Amazon's office, and they said, "Sounds great, submit it for certification." I submitted it and they said, "Denied. It turns out that this is targeting children." And I said, "Yes, it's targeting children, as many of your skills target children." And they said, "Oh yeah, we changed the rules. You can't have skills for children anymore."
When did they change it?
It's not necessarily for children, actually.
Right. So they did suggest that if I rejiggered it a little bit to have it be that the parent was asking the child and the child wasn't interacting directly with things, that they might approve it. But so there's a bunch of interesting things here. So sometimes things break, but you can look at the logs. I mean the logs. I just find it astonishing that I can just click and find the logs and I don't have to go hunting around for things.
Brian, was it written in Node?
Yeah, it was written in Node, and I don't know
Node
Node.
Lambda function?
It's what?
Like a Node, you can do Node, Python, Java, and C#.
Yeah. This one was written in Node, though.
Right.
And
Right. And the thing is, I'm a Java Scala guy, so I was like, and some Python. So it said, you can start out with templates, and it said, what do you want for your language? I'm like, Node. How hard can Node be? And it's,
I'm saying it, I get it.
One of the interesting things is since it supports Java, you can use any of the JVM languages. But now let's actually go back and look at a couple more things. And I want to show you the voice interaction model, because one of the things that's really hard with this kind of system is the voice interaction model of like, how do you do configuration? So I didn't show you how I configured what the chores are. It's tricky to make it not a horrible experience in voice. If it was a web page, you could list off all the chores and just say check off the chores, but that's not applicable to voice. Now a lot of Echo apps have a companion application, companion web page, or you can do but a lot of us are thinking, well, it's a voice device. I don't want to have to go to an app. That's not the whole point. So it's an evolving topic.
Was it done? Is there a single Lambda function?
I'll show you.
Okay.
We're going to go right into it. So this is this is the code, and 600 lines of code, and it was my first. This is essentially my second Lambda, and my first go at.
So
Node. So I'm sure that there's
slots.
What?
Where did you? There's another screen where you put the intents and the slots, right?
Yep. We're gonna get to that. So I mean, we can actually go there. Let's start there. So you basically get a developer account, and you say, you put in the name of the application, the invocation name, the thing you want it to be called by, and then you have this. Yeah, my wife's saying, knock it off, Brian. So you have intentions and then sample utterances, and the idea is every time that you say something to the device interprets what you're saying into an intention. So if I say, when I said, do I have to? So let's look down here. I've said.
It's on top, 17.
17. Okay, you know my code better than I do. Yeah, do I have to? So I have a bunch of examples of the I have intent, where I say, if I say yes, or yes, I've done the chore, or yes, I've done the, or if I say yep, I did it, those are examples of I have intent. If I say any of these things, I don't know, maybe I'll do it later, those are I didn't do it, I have not done it intent.
So,
okay?
so the idea here is basically what they're using is natural language processing, and your intent is what is a parameter which is only passed to your Lambda function, and these are the various ways you're training your NLP to get to it. So
Right.
it says I'll do it later. It's the same as do I have to or something like that.
Right. This is where you can really enhance the user experience. If it's just yes or no, that's not how we interact. I mean, I don't know about y'all, but my kid says, maybe I've done it. And I know that means no.
It's
you know,
possibility.
What? Yeah, maybe.
I think so.
And so, and then I have the intention to open the application. Now, one of the interesting things is that I didn't get into is set the time intent. One of the things with Lambdas and these wonderful little devices is Amazon is crazy concerned about privacy and not identifying you. And you notice it asked checking your afternoon chores. And then one time it said your weekend chores, and I would figure out why it said that. But it knows that this is not morning, okay? But how does it know it's not morning? This device will not report to the Lambda what the current time is. And it will not report what the time zone is. Because Amazon has stated that identifying that I'm, in Eastern Daylight, or Eastern, are we in daylight now?
Daylight.
Yeah,
Daylight.
whatever. We're in the East Coast someplace. That's identifies me too much. And it's like, are you kidding me? So one of the things you have to do for my skill when you're configuring it is you have to say what time zone you're in, or you say what time it is. And then we figure out what time zone that means you're in. So I have some intentions for set the time. My local time is such and such. And then there's a bunch of configurations for, list the chores, edit the configuration. I mean, you see that there's a lot more. A lot of this interaction is on the configuration, and just a tiny bit is yes, I've done it. Yes, I haven't done it. So those are the sample utterances, and then you have these intentions where you can say, you can create slots, and you can use the intentions, and so on. And so you make changes here and add lots of sample utterances, and then you basically compile this. And compiling this, which they do for you, can take a while. I mean, take a minute, a couple minutes, 15, 20 minutes sometimes. It can take a while. So that's the voice interaction model.
So when you wrote this, it's a dev question, right? How do you test it before you ran it? How do you write this script and try it out before you popped it in here, or could you?
Well, yeah. I mean, one of the things is, so this is actually my development console. I mean, if I make a change here and save it, then it's live.
It's there, right? Okay.
So I spent
Actually,
ridiculous number of hours editing. What? Alexa, ask more screen time.
Right.
Failure, you know.
Right, right, okay.
So actually what you do is on Lambda, you have the versions of your software and you can specify which version of your Lambda is production and which is dev. So you can, so if you, like in this case, you only got the latest version, so you can specify what is going to be the one used for
Yeah, no,
production.
I'm actually not asking, I mean, I think you had it right, I'm actually asking, is there some other, you know, some other way to build these things that's more rapid than, you know,
Well, actually,
saving it and testing it?
I actually found it really, you know, quite rapid. I mean, it's you know, I'd make a change here and, you know, push a button and then run it immediately.
Okay, so to your answer, you're saying you can just have two versions of the same thing. One you consider a prod version of the Lambda function, another one you're working on, you can swap them out.
Yes.
Yeah.
I've seen that before. Just wondering if there's some other, you know.
And the latest version of, I do not know, this Kindle or the Amazon app has got the Alexa built in for the iPhone and Android. So you don't really need to carry the Echo Dot.
Right. One of the things is so there's the Amazon app that you run on your phone, and until just recently, it could do anything except actually get talked to, which seemed kind of silly. And so a bunch of third-party apps came out that would let you talk to your device, and this has become a little cottage industry of pranking your spouse. So you can, you know, from home say, turn on the kitchen lights, you know, flash the kitchen lights, change the music, and that works well until your spouse kills you. You know, wow. My wife and I have an ironclad agreement that I will not ever do that because I'm not stupid. And this skill was written before Amazon came out with a newer version of the skills kit, where there's a lot of stuff that you do repetitively in these Alexa applications. Yeah, that didn't cover you.
She who shall not be named.
Right. I really
So why
should
do you
change it.
have two Alexa?
Oh, I just just to show, you know, I mean, this is tremendously handy for portability. I carry it around. You know, when it wasn't in always listening mode, the charge would last, you know, a bunch of days. Now that since it's listening all the time, yeah, it lasts, you know, 9 hours or something. But it has a charging base, and so this actually this one lives, you know, upstairs, and that one lives down in the kitchen, and you know, I mean, we're big fans. They come down and say, you know, what's on this, what's the weather, what's the calendar, what's the commute look like, and now we're starting to play with some of the smart light bulbs and switches and stuff. And it's actually fairly cool. The light bulbs are too expensive, but you know, what are you going to do? But what I was saying is, there's an interaction model that you tend to do with these guys, where you carry state around in the session variable that gets passed to each invocation of your function. So one of the things that it's core to my more screen time skill is, the first time you start it, it figures out what the time of day is. It goes and loads what the skills are, and then it says, okay, it figures out what the chores are, and then it says, okay, I'm on chore 0. Did you do chore 0? Okay. Then I say yes, and it says, oh, you did a yes intent. I'll call the function again with the yes intent and the list of chores in my session attributes, and the index now is 1, and you know, I just move along. So there's a lot of code to manage the session variables. Well, they come out with a new version of the API that builds a lot of that in. And so if I rewrote this, I could probably, you know, cut the code in half or something. But you can see that, and I'll just walk you through some of it. So, you know, again, I have the handler function, just like the one for the S3 bucket for the text messaging. You know, I check that it's actually my skill, so no one else is coming in. if it's a new session, I go to session started, I go to on launch, blah, blah, blah. I go to here, particular intent, and this is not, this code is not going to win any prizes, but it's horrible, if else, is it the I have intent? Is it the help intent, is it the stop intent, and so on, and then I go to, a bunch of handlers. But in each one of these, I'm dealing with session variables. Get time of day, they make it ridiculously hard. It shouldn't, to figure out, I shouldn't have to write this much code just to figure out the, what time zone I'm in.
Right.
But, and all the usual boundary cases that, I should never have to do. There's times when I need to figure out what my chore list is. I go figure out who the user is. I go to their S3 bucket, based on my more screen time, key, and I get what their list of chores are, and I stick them someplace in here. I stick them into a session variable. Oh yeah, stick them into a session variable. So that's sort of the pattern. And if you're doing this in Node or Python, you just make changes here and push save and carry on. If you're writing in Java, you can't edit in here. You basically go do your edit in your favorite IDE, upload a jar, and then run it. And so then the cycle time gets a little bit painful. I will say this editor, it's okay for 600 line file. I wouldn't go too much beyond there. But on the other hand, maybe you shouldn't be writing a giant lambda. Maybe you should be writing a sea of little lambdas that all call each other using step functions. So I think that's what I got. So
Awesome, thank you very much. Yeah, that's great. Yeah, so I think we all got up for this, right? So thank you very much, Brian.
My pleasure.
For making the trip is a long trip, to Maine, for vacation land.
Yeah.
Right, I had some notes, I just thought, okay, so.